Okay, here's yet another statistics problem. This problem is we suppose that test scores are approximately normal with a mean of 72 and a standard deviation of 12. Part A, if 16 scores are randomly selected, what is the probability the average score is less than 70? In other words, if we take 16 at random and we form the average, what's the probability that that average is less than 70? Well, again here, what we're doing is we're doing a sample of 16 samples, xi, and we're doing the average of all of those samples to produce the sample mean. We're given that the underlying probability has a mean of 72 and has a standard deviation of 12. Now, we know that the standard deviation of the sample mean, x bar, is equal to sigma divided by the square root of n. In this case, that's 12 divided by the square root of 16, which is 4 or 3. And now we want to convert this to a normal score, which I call z bar. And z bar is equal to x bar minus 72, the sample mean, divided by 3, which is the sample variance. So we want to find the probability here that x bar is less than 70. But we substitute in place of x bar, we substitute in 3z bar plus 72. That's 3z bar plus 72 is equal to x bar. So 3z bar plus 72 is less than 70. Rearrange terms a little bit. This becomes a probability that 3z bar is less than negative 2, or the probability that z bar is less than negative 2/3. Looking at the z-score calculator, I compute this as being 0.25. Hope I didn't make a mistake. Now part B of the problem. If one score is randomly selected, what is the probability the score is above 60? Okay, so in this case we're picking one sample, xi, and that represents the sample mean. N is equal to 1. S, which is the sample standard deviation, is equal to sigma is equal to 12. So z bar in this case is equal to x bar minus 72 divided by 12. The probability that x bar is greater than 70 is equal to the probability that 12z bar plus 72 is greater than 60. We get that from this equation here for relating z bar and x bar. Then this becomes a probability that 12z bar is greater than negative 12, or the probability that z bar is greater than negative 1, or 0.84. Probability that z bar is greater than negative 1. So I looked this up in the z table and got 0.84. So I hope this is right also, and talk to you next time.